Hello, everyone. It's Carolyn, and I am going to be talking about just doing one example of a binomial distribution, similar to one that I'd started before. In fact, it is almost identical to it. And this time I'm going to be using Excel and StatCrunch to help me get to the answers, which is going to save us a lot of time in the calculations. I will kind of remind us of the formula and what we would have to do to evaluate that if we were using just the formula. So first of all, I'm going to remind us of what this experiment is. So we are rolling a die 12 times. And what we're going to do is we're going to let X be the number of times that we see a 4. Okay, this is a binomial. Remembering a binomial has 4 criteria that are out there. The first criteria is that you do the trials. We have a fixed number of trials. And in this case, we are rolling our die 12 times. Each of those trials is independent, meaning what happens on one doesn't change what happens on the other. And we are rolling a die. So every time we pick up the die, we still get the same probability every single time. The trials have basically 2 outcomes or could be reduced to 2 outcomes. In this example, although there are 6 outcomes when you roll a die, we have reduced it down to seeing a 4 or not seeing a 4. So yes, you see a 4 or no, you don't. And then our probability of success seeing that 4 has not changed. And in fact, it is that 1/6. For this first one, I want to calculate what is the probability that X is equal to 5. In other words, out of these 12 rolls, we saw 5 4s. I'm going to remind us of what that formula looks like, although we're not going to use it. We're going to be using technology. But I just kind of want to remind you what it is, so you can have it in your notes or kind of refresh your memory. All of the things you would have had to do if we didn't have technology. So this is the general formula. I did use the combination piece. And in our problem is 12. So we would do a 12 combination 5. X is that 5. P is the probability of a success. So that in our case is 1 out of the 6 because 1 out of our 6s is a 4. And we're raising that to the 5th power. 1 minus P, that's everybody else. So that would be 5 6. And then N is your 12 minus 5. So that would be 7. So you would have to calculate that value, which we could do because it's only one little piece. Things do get a little harder when we have questions like the ones that I have here. I will go to technology for all 3 of these at the same time, but I want to avoid all of my screen flips. So I'm going to be setting them up, and then we'll go to technology and get those answers. So here I want to know what is the probability that we see a 4 at most 3 times. So that means we need to remember what at most is. At most means smaller, and that we also do see the 3. So if you're looking for symbols, X at most is going to be less than or equal to 3, which means X is going to take on the values 0, 1, 2, or 3. So if we were doing this by hand, this is where the by hand part gets really kind of ugly, is we have to calculate it for each of those pieces. So this formula here, changing my numbers a little bit, changing that 5 and that 7. For X is 0, X is 1, X is 2, and X is 3. And then we would add them together because they are disjoint events and they have no overlap. So we find the probability of each one, and then we can simply add those together. Okay, but we will see with technology, it doesn't take any time whatsoever. All right, here, what is the probability that we see a 4 at least 5 times? So this is, again, if I put it in my symbols, X at least, that means 5 is the smallest. We're going to be bigger than 5, but we're also allowing it to be 5, so at least, versus more than 5 times. Okay, up here versus less than 3 times. So again, if I were doing this by hand, we would start at 5, 6, 7, 8, 9, 10, 11, and 12. Although when I'm using my technology, I'll remind us of some other things that we can do to help us. Okay. So this is x is equal to 5, 6, 7, 8, up all the way up until 12. Okay. And actually, I think what I'll do is I'll remind us, we could have done this, right? Or we can take 1 minus the bottom end. So x equals 0, 1, 2, 3, and 4. So probability x less than or equal to 4. This would be a little bit less calculator work if you were doing it by hand, because you'd only have to calculate 5 versus here we have a few more. And then we can add those together, and remembering all our probabilities add up to 1, so we can subtract from 1. Okay, but now I'm going to go into technology, StatCrunch, and into our Excel. Those are my 2 favorites, and actually get these values. So first thing I'm going to do is stop sharing this screen. Excuse me. And I am going to share a different screen, namely my StatCrunch screen. And I'm hoping that you see both StatCrunch and Excel. Probably do not. So right now I'm going to see, you see StatCrunch. So what you're going to see is in StatCrunch, what we're going to go into is under Stat. So again, StatCrunch, you're into Stat. You're going to go to Calculators, and you'll go to Binomial. Okay? And it's going to pull up whatever you had before. And it's given me some other stuff here. Wonderful. So I need to get rid of that. How do I get rid of that? Oh, we got pop-up screens here. Go back here, Carolyn. There we go. Okay, so there we have StatCrunch. I need to change my N. My N is the number of trials that we're doing. My P, that is my 1/6. You can enter fractions, and I would enter fractions. Here we want X equal to 5. So the nice thing about StatCrunch is it automatically also graphs the probability distribution for you. And we had talked about graphing probability distributions. And you can see it is a little skewed, because you'll see these tail off a little bit here. I have my answer right there is my 0.02. I'm going to write it down on my paper so I don't forget it. So when I go to Excel, we can say, yes, we got the same answers, because I will have written it down. Okay, and you'll notice here also that this 5, where the 5 is, that's our red bar. So that's showing you what it is actually calculating. Okay, that was the first question. For our second one, we wanted the same problem, but we want our X to be less than or equal to, and the number 3. So not 5, but 3. And then I'm going to compute, and we get 0.87482191. Yes, and you'll notice we can see the 0, 1, 2, and 3, and they are taking those probabilities and adding them together. So here's a little bit more than 0.1, 0.25, about a 0.3, another 0.2, adding them together to get that 0.8748, on and on. Okay, the last one we want to do is we want to go greater than our 5. And that is going to be 0.0363502. Okay, and again, you can see the picture. Here's my little red pieces. You'll notice that there's not much there, because getting 8 4s when you're only rolling 12 is going to be very difficult to do. It's kind of like, start to think that if that happens, the die is loaded. So, here's half of them. So if half of our rolls turned into a 4, something's going on. So that's why this hasn't changed much from that first number that we did. All right, so this is how you would use StatCrunch. Again, to kind of remind you, we went into Stat, under the calculators, into Binomial. Okay, I'm going to stop sharing here, and now I'm going to go into Excel, my Excel sheet here. I'm going to make it a little bigger so I can see it myself. Excel, you just need to put yourself in any empty cell. And the reason I like to show Excel is because, yes, you have access to StatCrunch right now, but after you are done with this course, or if you're not taking the course from me currently, you're just watching my videos, you may not have access to StatCrunch. I do not believe StatCrunch is a free system out there, but Excel is something that a lot of people do have. Also, is very similar to Google Sheets. So Google Sheets would also have something similar to this. So I just kind of show it in Excel, and hopefully you guys can make the adjustments. But you're going to click on an empty cell, and I'm going to use my little FX button here because I'm going to insert a function. I would change this category from, it's usually on most recently used, to statistical, because this is a statistical program or function that we're going to be using. And the one we want to use is binomial distribution. So this BINOM.DIST, standing for binomial distribution. And we're going to press OK. This one works a little backwards. So this one wants your X value first. So for our first one, we had that X was 5. Our number of trials, that was, we were rolling our die 12 times. And I'm going to type in my 1/6. You'll see that they automatically switched it to a decimal. But in its system, it is carrying quite a few more digits. So it is keeping basically the 1/6. This one allows us to accumulate. Accumulating means starting at 0, going up to this value. So I'm going to put in the word false, because I just want to calculate just the number 5. So there's my 0.028 that we had previously. And I'm looking at my scratch paper where I wrote it down, and yes, that is exactly what we had in StatCrunch. So here, I probably should put like X equals 5 here, huh? That might help us. And we can do X. I'm going to do our next one was less than and equal to, and our number we had there was 3. Okay. I am going to again go into my function, get my binomial distribution, hit my OK. This time I want to go from 3 on down. So this I'm going to put in the upper limit, the 3. We still had 12, still the 1/6. And this time, since I want to go from 0 all the way up to 3, I'm going to write the number true, because that's going to add those pieces up for me. And I'm going to hit OK. And there's my 0.874822. In StatCrunch, it gave us a few more digits. I could probably get some more. There we are. So the 19, they had 191. Here they have 1907. So again, the exact same thing. This one, we wanted to do X greater than or equal to 5. Okay, so this is where I have to be a little bit tricky. And what I'm going to do is I need to make sure to do 1 minus, because cumulative only does from 0 up. It doesn't go from a certain point all the way to the end. It starts at 0 and starts adding up to the top. It's just the way the system was written. And there's a couple of ways we can do this. I'm just going to go in here first of all and get the binomial distribution. I'm going to do from 0 to 4. So that's my bottom end, because if I want to go 5 up, we're going to take 0 to 4 and then subtract it from 1. So 12, my 1/6, and I'm going to type in the word true. Oops, what didn't I do? Oh, I didn't spell right. That's supposed to be an E, not an S. Let's try that. There we go. 0.9, but that's not what we had. because I need to take this and subtract it from 1. So in this next cell, what I'm going to do is type an equal to symbol. If that's telling Excel, I'm going to type in a formula. It's going to be doing some math. And I want to do 1 minus this number. So I'm grabbing that number. And there's the 0.036355. I could have typed all that in to begin with. So I could have done equal, letting Excel know I'm doing some math. I can do 1 minus, and then I can go up to my function and get that binomial distribution. There was my 4, 12, 1/6, and true, provided I spell it correctly this time. And you'll notice we have the exact same answer. So you could do it all in one if you remember that's what you want to do. But remembering the thing with Excel is that cumulative only starts at 0 and goes up. In StatCrunch, we have the flexibility to choose whatever symbol we want, the equal to, greater than or equal to, less than or equal to, and the straight greater. So we have all 5 options for us. So I am going to stop sharing and actually stop this video. I will do another video with a different example and kind of redo this again. Probably not as many situations, but just so that you know. All right, and I'm also going to stop